Alright, this is section 1.2 from Algebra 2. I'm going to go quickly over things, pause where you need to. Some points where I'll say pause, some points where you might want to pause without that. So section 1.2 is evaluating and simplifying expressions. First thing we need to talk about is evaluating powers. So if we look at these 7 squared, negative 7 squared, and negative 7 squared, there is a difference. The first thing, remember this part, this negative 7 is, 7 squared is 7 times 7, which is simply 49. Over here, when we have negative 7 squared inside the parentheses, that means it's negative 7 times negative 7. Negative times a negative is a positive, so again we have 49. Now we have negative 7 squared. That means we take the negative, or the opposite of 7 times 7, which is really going to be negative, the opposite of 49, which we can simplify to just be negative 49. You guys can look and notice a difference, and now see the parentheses make a huge difference. So I'm going to look at this next problem. What is the difference here? I want you guys to pause, and I want you to try this for yourself. Alright guys, here's what I got for my answers. Please check your answers, make sure you got the same thing. If you notice, parentheses make a huge difference. Alright, now we're going to talk about the order of operations. The order of operations, you can have a couple different ways you can memorize it, but you got to just make sure you go in the right order. The way that I always learned how to do it was PEMDAS. The other way to think about this that some people have heard of is PERMDAS. I'm going to personally stick to PEMDAS because that's why I learned it and that's the way I remember it. So PEMDAS, P-E-M-D-A-S. So that P is parentheses. You want to do what's inside the parentheses first. Then the E is exponents. And the reason why I don't use the R, ponents, not exponents, exponents. The reason I don't use the R is because what this R stands for is radicals, and technically radicals are the same thing as exponents, so I keep that in the same thing. Next is multiplication, divide, and lastly addition, subtraction. Now a common mistake that people make just because it's PEMDAS and multiply and divide, multiply comes before divide in that acronym, these come at the same time. So you go from left to right for which one of those comes first. So if multiplication comes first from left to right, then you do that first. If division comes first from left to right, you do division first. Similarly with addition and subtraction, left to right. So make sure you go from left to right, adding, subtracting, multiplying, dividing. So now let's do some examples of what I'm talking about. So this problem, we have to think of what we need to do first. Well, we should do parentheses first. So we should do what's inside the parentheses first. So 3 plus 4 times 2 minus 1 is 1 squared divided by 4. Next thing we're going to do is we're going to do exponents, which means we need to do the 1 squared part first. So it becomes 3 plus 4 times 1 divided by 4. Alright, now we're going to do multiplication and division first, remembering to go from left to right. So you can see there's multiply and there's divide. But the multiply comes first from left to right, so we're going to do that first. So it's going to be 3 plus 4 times 1 is what we're going to do. So plus 4 divided by 4. Again, we have division here. We need to get rid of that, so we need to do 4 divided by 4. Well, that's 1. Last but not least, we're going to add those two pieces together, and we're going to get 3 plus 1 is 4. There's our final answer. Now this last problem, I want you guys to pause, and I want you to try it on your own, and then check your answer. Here's what I got for my answer. Check your answer to make sure you got the same thing, and if you didn't, check where you made a mistake. If I made a mistake, let me know. Alright, next thing we're going to talk about is evaluating an algebraic expression. So first thing we need to talk about is what makes an algebraic expression. Well, really what makes an algebraic expression is the variables being in it. That makes it algebraic. Remember, an expression is when you don't have an equal sign. So 3 plus 4 is technically an expression. When we have an algebraic expression, we start adding variables into it. And what a variable is that it is a letter that is used to represent one or more numbers. If you guys look in your book, that'll give you guys more definitions of it. I'm not going to write that out. What a coefficient is it's the number that is in front of the variable. And what a constant is the number without a variable in the algebraic expression. So an example, if we have 3x plus 4. In this example, x is my variable. In this example, 3 is my coefficient. And in this example, 4 is my constant. Now if I clear that out and I try another example, if I have something like 3x plus 9z plus 8y minus 4, you can look, we have a lot of different variables, or we have 3 different variables, we have 3 different coefficients, and we have 1 different constant. So I'm going to circle the variables in red. There's a variable, there's a variable, and there's a variable. You can have more than one kind of variable and still be an algebraic expression. Here are my coefficients. I can have more than one coefficient. Now, a fully simplified algebraic expression will only have one constant because you can combine the constants together. All right, so let's do an example here. First thing we need to do to simplify and evaluate is we need to plug in that -4 for m. So all we're going to do is 3 times -4 squared plus 5 times -4 minus 12. So let's simplify this using our order of operations. Parentheses first, well, they're already simplified in the parentheses, so all I'm going to do is I'm going to do my exponents next. So 3 times 16 plus, well, I have no more exponents, so I'm just going to rewrite it. Now I'm going to do my multiplication from left to right, and since there's an addition in between the two multiplies, I can do those at the same time. So we can do 48, and it's to become negative minus 20 minus 12. And then from there, all we have to do is combine our terms. So 48 minus 20 is 28. 28 minus 12 is 16, would be our fully simplified version. Now I want you guys to try that on your own with that last problem there. Now by pure coincidence, we got the same answer of 16. Make sure you check your work. Make sure you did it right. If you didn't, pause it and see where you went wrong. All right. So let's simplify some algebraic expressions where we have the variables in there. Well, simply in this part, we look for like terms. And what I mean by like terms is we need to look at the variables. Notice that n is the same as n. So really, if I have 12 n's and I subtract 7 n's, all I really need to look at is 12 minus 7. Well, 12 minus 7 is 5, but we don't have 5, just 5. We have 5 n's. It's as simple as that. Look over here, we have multiple variables, so we need to go to our variables that are the like variables. Here are my like variables there, and then we have y's together as well. So I'm going to simplify those piece by piece. First I'm going to do the y's because the y comes first. I'm going to do -4 plus 1y. Well, that's going to be -3y. And then I'm going to do -x plus 10x. Well, we know that's -1x, so plus 10 would be positive 9x. And that's the fully simplified because we cannot combine unlike terms. Y and x are different, so we cannot combine those. Now I want to look at this problem, and we're going to do this one because first we have to distribute that 8 through to each piece, and then the 2 through to each piece. So we're going to end up with 8x minus 24. -2 times x is -2x. -2 times 6 is -12. Now we'll combine our like terms again. So we have 8x and we have -2x. So that leaves us with 6x. Then we have -24 and -12. So -24 minus 12 is -36. And we are done. Cannot combine those anymore because they are different variables. We have a variable and a coefficient. We cannot combine those. Let's look at some of these problems. I want you guys to try them on your own. So there's 4 problems here I want you to try on your own. I'll put the answers up shortly here. Pause it and check your answers for each one, please. All right, here are the answers to the 4 problems. If you guys didn't notice, one of those problems was the exact example that I just previously did, but it's good to try that one on your own as well. So here are the answers. Check them, correct them if you need to. All right, the last thing we need to talk about in section 1.2 are word problems. So let's go over this word problem. Yesterday I bought 30 pieces of candy. Well, that seems kind of important, 30 pieces of candy. The gum, so I'm going to underline gum, costs 50 cents each, and the Laffy Taffies cost 75 cents each. So write and simplify an expression that represents the amount I spent on candy if X represents the number of Laffy Taffies. Well, if we look up there, Laffy Taffies I did in green, so X equals the number of Laffy Taffies. Now you guys might be thinking, hey, let's give another variable to my gum, but we really don't need to give another variable because we know how many total packs or how many pieces of candy were bought. We know there's a total of 30, so we really know that 30 minus X is going to equal the number of gum we bought. So now let's go and let's write our equation for how much we spent. Well, candy, so the gum costs 50 cents, so I'm going to write 50 cents times 30 minus X. And we also need to worry about how much the Laffy Taffies cost, and that costs 75 cents. And we do the X there. Now, if you guys didn't notice, we're talking about how much cents I spent, not how many dollars I spent. That would change things up. So now we need to simplify this by distributing through. Boom, boom. So we get 150 minus 50x plus 75x. Now we have some like terms, so let's combine those. So it'll be 150 minus and negative 50 plus 25 is actually going to be, sorry, plus 75 is going to be positive 25x. And that's our fully simplified version of how much money we would spend on candy. All right, I'm going to let you guys freeze this one here, and I'm going to let you guys try it on your own. So here's the answer I got. The 3x plus 720 will tell you how much it would cost. Now I'm going to go and I'm going to insert the total income if 38 of the 60 DVDs were brand A. And you can see on the right, since X was the number of brand A sold, all I had to do was plug 38 in for X, and I got my total was $834 worth of product. So here, that was 1.2. Please feel free to rewind, pause, do whatever you need to do to make sure you understand the materials.